Why are axioms independent in advanced geometry systems? Imagine building a house where each brick is essential and cannot be replaced by another. That's what independence means for axioms in advanced geometry systems. It means no one axiom can be proven from the others. Each one stands alone as a fundamental truth. If you could derive one from the rest, it wouldn't be needed anymore. But because each axiom is independent, it adds something unique to the system. This keeps the system simple and clear. Now, what exactly is an axiom? Think of it as a basic rule or assumption you accept without proof. In geometry, axioms tell us how points, lines, and shapes behave. For example, in Euclidean geometry, one axiom states that through any two points, there is exactly one straight line. Another axiom says that all right angles are equal. These are starting points that help us understand more complex ideas. The reason independence is so important is that if one axiom could be shown to come from others, it would be unnecessary. That would make the system more complicated than it needs to be. Independence guarantees that each axiom is essential. Take the parallel postulate in Euclidean geometry. It says that given a line and a point not on it, there is exactly one line through that point parallel to the original line. This axiom is independent because it cannot be proven from the other axioms. If you remove or change the parallel postulate, you get a different kind of geometry. For example, if you say there are many lines through a point that don't meet the original line, you get hyperbolic geometry. If you say no lines are parallel, you get elliptic geometry. This shows how crucial the independence of axioms is for exploring different spaces. Proving that axioms are independent usually involves creating models or examples where all but one axiom are true. Then you show that the remaining axiom can be false without causing contradictions. This proves that the axiom isn't a logical consequence of the others. It's like proving that a piece of a puzzle is necessary because without it, the picture doesn't make sense. Having independent axioms helps mathematicians and students see exactly what assumptions lead to which properties. It also makes it easier to explore alternative geometries. In advanced systems, where shapes can be curved or spaces can behave differently, independence allows us to change or replace axioms to see what new worlds we can imagine. In short, axioms are independent in advanced geometry systems because each one is a necessary, unique building block. This keeps the system simple, flexible, and clear. It helps us understand how shapes, angles, and spaces work by breaking down complex ideas into straightforward, manageable rules.